algorithm is a step-by-step process for doing something. We can call an algorithm effective if it does what it's supposed to do. In other words, if following the instructions will get you to the outcome. What I'm asking you to do is look at the things you see in your life. Do you see any algorithm? Or do you notice any algorithms that you have? Here's a bottle of Selsun Blue shampoo. On the back are directions for how to use Selsun Blue shampoo. So you see the directions right. Wet hair thoroughly. Massage onto scalp. Rinse twice a week or as directed by a doctor. So really, the algorithm is 3 steps. Wet hair thoroughly. Massage onto scalp. Rinse. Now, if this is going to be a good algorithm, the algorithm is not vague. It's very clear. It has basically no room for interpretation. In the case that you can get a robot to follow these instructions. And if you don't know any robots, think about the most literal person that you know. All of us have a friend, or in this case, I am the friend, who has no sense of nuance, who whatever you tell them to do, they do it exactly as you tell them to do. So you either have seen a robot and can conceptualize a robot, or you have a friend who just reads the lines at all. And that's the intended audience for an algorithm. Do you see any issues? What are the issues with this algorithm? Okay, so it doesn't say how much shampoo. That's a major issue. Should I use the whole bottle? You're right that robots don't have scalps. It does not say what to wet the hair with. That's another. What else? Doesn't say when to rinse. Rinse it away or what? Let's sit for 10 minutes. Let's sit for 5 days. What? It doesn't say. You could get arrested following these instructions. So, you know, this might work for human beings. These might be reasonable instructions. This is not a good algorithm. Way too much room for interpretation. In a good algorithm, we don't want any room for interpretation. We want to break it down step by step so that there's no possible chance anything could go wrong. Think about, as you're going through your everyday life, do you have any algorithms? I'm doing laundry today. This is my daughter's shirt. I have an algorithm for first, I take the sleeves at the elbows and I pull them together so that the shirt is in half. First, I ask the cat to leave so I can fold this shirt. Try to get a space with no cat. I'm going to fold it back so that the sleeves meet, and then I'm going to straighten. Then I'm going to fold the 2 folded sleeves together back so that I have a rectangle, and then I'm going to fold it in half. Then I'm going to check the tuck to make sure. So this is how I put the shirt away in the drawer. So this is my algorithm for folding. Obviously, I know this process. My question is, do you think I could give someone else and just say, okay, I'm going to pay you to fold these shirts. Here are the instructions. Do you think they could do it with these words? I hope so. And if not, I need to clarify it. Someone else can do it. And so now here's the key question. And your challenge for find algorithms as you go through the house, as you go to the grocery store. And the recipe is a really good example, but recipe is an example, so let's not use that one. And then critique them. Are they clear? And these don't have the algorithms that are written down. Maybe you have an algorithm for something that you do that's not written down, and you could write it down and share it. What are some algorithms you have seen in math classes? About it. Formulas, definitely an algorithm. Taking derivatives. Multiplication, there's an algorithm for multiplication, right? You learn it. There's a division algorithm. These are all examples of algorithms. The biggest misconception people have about math is they think